Ladies and gentlemen, WeatherBrains episode number 683 is on the air. The pre-show for the 18th of February, 2019. The most magical part of this program. We share boring personal stories, humorous anecdotes, and occasionally say very outrageous things. So every time, Bill, in fact, let me flip the camera here.
Yeah.
So this is what's on TV right now. This is on my channel, and I typically have this thing monitoring. It's the Bachelor, and I think about JB. I miss JB. Those ladies were naked on that program. It's like
put some clothes on, Ethel.
Yeah, put some clothes on. So
do you remember that song, "The Streak"? James?
Oh yeah, Ray Stevens.
Did you ever play that on the radio, or was that too?
Yes. I was working. The Streak was a hit in 1974, and I was a teenage disc jockey in high school, playing that song on the radio. That was a very bizarre era. So
bizarre song.
It was. So I just did almost a 90-minute interview.
On what?
On communicating weather, mainly tropical weather. It's a research project. This was a PhD student working on a large project with the University of Colorado Boulder and the National Center for Atmospheric Research, NCAR, on how broadcast meteorologists communicate hurricane risk. Of course, the first thing I said, I'm not really in a hurricane market, but we're affected. But this is social media.
But you're the National Weather Person of the Year. You're big time then.
I'm just a stooge. The thing is, social media knows no boundaries. There are no county warning areas. There are no designated market areas like in television or in the Weather Service world. So you just, So anyway, we talked for almost 90 minutes. So I was over on Skype with those ladies from Colorado University and NCAR. And I told them, be sure and send me your research, because I told them, I don't know what's right. I don't know what's wrong. We are all learning this together. Now they got him crying.
Oh no.
Oh boy. She's in Atlanta.
Crying or he's crying?
No, it's a lady here. I think she's from Tuscaloosa.
They're always from Alabama. What's the deal?
I don't know. I bet you she's a WeatherBrains. She might be a WeatherBrains viewer. She may be watching this right now. You never know.
Why are they watching? I was going to say that's your computer. I was like, why are we watching this on a Vizio computer monitor?
Yeah. This
Do you know how cheap these things are now?
Yeah. So what I've got up here. I was going to say that this TV, I think, cost about $100 or maybe $80.
How big is it? 24 inches?
I don't. It's not that big, but I bet
it's $69. We went to Best Buy Friday night to get a new television for one of our kids, and the 32-inch television, 129. I had no idea. I wasn't paying attention. I just saw 129, grabbed it, and realized 10 minutes later that I should have bought the 39-inch for 159.
Yeah, it's cheap, man.
And it's got all the stuff on it. You don't have to have the Fire Sticks or the Chromecast or anything. It's just built into it, man.
Right. The Netflix is all built in. But what I do, I use it as a monitor for that Mac Mini up there. There's a Drobo, a storage unit, and some speakers and another drive up there. But mainly, it's just a monitor for that Mac Mini, and it's just like under $100, and it's a really nice. It's perfect for what I need it for. And if I need to monitor, I like to watch tornado coverage on other, other markets, and I can put it up full screen on there, and it looks just great. So it's, but
I got my monitor.
The Naked Woman show is always on Monday night during the show.
Yeah, either that or Dancing with the Stars. Yeah. Here's all my little weather setup right here with all my monitors. So,
man,
but I just got this one orphaned from the office because nobody needed it anymore. Because nobody uses a desktop computer anymore. So,
I don't have as many. I got that for radar, mostly these tablets.
Well, that's mainly why I put this one up there, because I repurposed an old MacBook to just be my radar scope computer. Because I had about a 15-year-old Dell laptop that was running GR level 3, and it just gave out. All right, we need Dr. Evans to come along. I sent her an invite, I believe, and I don't see her.
Where's everybody else? And we know that Kim is out.
Just us. What is the deal?
Due to illness. And Aubrey has a winter storm approaching, and she's out. But I've not heard from anybody else. So.
Troy's giving a test.
Right. Troy. Yeah, Troy's out. So John should be here, and maybe Nate.
Did I not send the invite? I did.
I've invited everybody the way the way I do it. I invite it straight from the. I don't send an email. I just send straight from the Hangout here.
Yeah, well, I will let you do that, James. Hold on a second. And I will go over here and type her information in here. I told her it would come by email, and we practiced a lot. Had like 3 Hangout tests. It was a big brain I didn't even know about.
She's at Penn State?
Yeah, from Australia. And, all right, there we go. So try that. Hey, Sue. When does the banana pudding get here, darling? We're having banana pudding, James.
I'm about to say, man, don't be calling me darling here. That's getting really creepy.
I would never call you darling.
I mean, I know we're longtime friends, but
not that there's anything wrong with that.
Very. That is a show title, by the way. When is the banana pudding ready, darling?
That is a perfect show title. I'll have to use it in the main part.
But we can't.
Oh, I'm getting it right now. It's coming right now. It's on a mobile cart. It's like room service.
I had low-fat yogurt after the ladies talked to me from Colorado. That was my dinner.
Low-fat yogurt. Well, I'm having high-fat banana pudding.
This is it right here. Publix.
Oh yeah,
fat-free
brand. Oh, it's yogurt. That vanilla yogurt that our son Nathaniel likes. I'm like, give me some blueberries or something in it.
No, you can put stuff in there if you want to, but I don't have anything to put in it, so it just was plain vanilla. So,
Dr. John saving the day.
Dr. John.
Why is she not here? This is not good. I just talked to her 5 minutes ago.
Oh, really? Wow. The last time I played that for a long time, we got a dirty email. I got a dirty email.
Really?
Yeah, about playing copyrighted songs, and don't do that again, and stop it, and you're bad.
That should be in like the eminent. Is it eminent domain? What is it called? The public domain.
Yeah. Well, again, you in theory, from what I don't know if this is true or not, but a lot of the lawyers said you play 30 seconds and you're okay. It's fair use. But if you go over 30 seconds, they can make a claim on you. And I will say I played it pretty long one night for some reason.
Well, they could sue us for all of our revenue.
Oh yeah,
they wouldn't get very far.
So I'd lose my salary here, huh?
You got that right. Yeah.
Yeah.
We're going bankrupt.
Was it Dr. Hook that sang "Nothing from Nothing"? No, that was Billy Preston.
Preston.
Oh.
Nothing from nothing leaves nothing.
Nothing. That's right.
Rick Rollin.
My 15-year-old was playing that in the car while we were driving around the other day. Just not like as a joke.
I don't even think Rick rolling is a thing anymore. I think that was I don't know, like 10 years ago. So nobody.
Mr. Astley has reclaimed his role as a rock icon.
Those days.
All right, we got to have some El Presidente here. We're not getting any El Presidente.
I have invited her my way, and if you've sent your email,
hey Bill, I used your link. It was fine.
Yeah, was she on there? She was on there, wasn't she?
Oh, I didn't even check. Let me see.
See if her name is on there.
Yeah, she's on there.
I think I have it right.
Maybe she realized that she needs to run. She realized what she's getting into.
She kind of realized that when I was going over some topics to talk about, because I brought up the weather boy fracas, global warming and AccuWeather. what are we going to talk about then?
let's play the long buzzer.
I told her not to get offended when that happens.
No, there's a lot of things we can talk about. I got all kind of.
Oh no, we got a long list. She thinks it's going to be a 3-hour show.
It might be.
We'll talk about the weather down under. But I think she ran.
I'd just like to hear the act. Yeah, she clearly saw what this is about and just headed the other way.
She asked me how many people watched. I told her around 10 to 15,000 in an average week. She said, "Now you're trying to make me nervous." Nah, it's just us girls.
We should have sent our country list of all the countries that listen to this show.
Right.
Right. We're big in Estonia.
We're big in Ireland.
I'm going to be in Ireland, James. I'm going to have to get some people at the Temple Bar in Dublin.
What you need to do is have a WeatherBrains meetup in Dublin. That would be awesome.
That would be at 2:30 in the morning. That'd be perfect.
Wow.
Yeah. So if by chance you're watching this,
yes, that's
we're
right.
Make
we're
that
going
happen.
to the Temple Bar in Dublin. That's where we'll be. Monday night,
Bill,
27th of March. No,
my understanding is Guinness from the tap out there is a whole lot different than the Guinness we drink here.
Well, I can't wait to find out.
Yeah,
I've only ever had one Guinness in my entire life.
Oh, you have to let me know.
I'm gonna start working out. Hey, how long has it been snowing at the Horseshoe Curve? Because I've been looking at this for about a month, and I think it's been snowing the entire time.
Where?
John, that question was
Where?
for you. At the Horseshoe Curve. What do you mean where? It's right in your backyard. The Horseshoe Curve. Are you not climbing it anymore?
What do you mean the Horseshoe Curve?
The most famous rail attraction in the United States, one of the most famous in the world.
Oh, I'm sorry.
Is the Horseshoe Curve. There west of Altoona.
I've never been on it.
Oh my goodness!
I'm
We're gonna
sorry.
have to fix that, Dr. Scala.
I'm sorry.
It literally looks like a horseshoe. It's like hugs the side of the mountain all the way around. It's 4 tracks, Norfolk Southern Main Line. And,
I've seen the pictures, but I have never been there.
It's spectacular. Well, the AccuWeather people took me there in 1996. They took me there in the Galitzin tunnels, and the shops at Juniata. I'm naming places all in your backyard there.
Those are in my backyard, but I have never been there. Of course, I've been to Strasbourg and ran rode the rail line there. We went to Steamtown in Scranton. Scranton, right?
We didn't
my
do any
son
work.
goes to school.
We just did trains the whole week. Well, Dr. Evans, we saw you briefly and you went away.
Oh, I'm here.
No, well, we can hear you. That's the most important part.
If we get your video, then we'll be in great shape. And most people listen anyway, so
there you go.
Bingo. It works.
Okay.
Now, you were suggesting a platform that we might move to when Google pulls the plug on us, Dr. Evans.
Zoom.
You hear that, James?
Zoom?
Yeah, I'm aware of Zoom.
Penn State looked into a bunch of platforms you can do. I was just talking to our vice president today. He had 8 people in separate Zoom sessions talking together. No problem. And right before I came here, we were doing it with Australia. No problem. It doesn't drop. Yeah, it's really good.
Now, from her MacBook Air, James, this morning, if she initiated the call, it worked. But if I initiated the call, it didn't work. But then if I initiated the call to her iPad, it worked fine.
What, you mean Hangouts?
Yeah.
Yeah, I don't, Google, we shouldn't talk bad about them. They might yank the plug here, but that they have this habit of, creating these platforms and they go away. Like, remember Google Wave? That platform they had?
We all got behind all these things they've come up with.
Yeah, you get all excited and you start using it, and then like 2 years later, it's gone. Google Plus was their social network, and it's gone.
Right.
It goes away, I think, the 1st of April. And I was hoping that would make it because it was like Facebook without the stupid. It was, it had good engagement. The conversation was good. There were no trolls. And let me welcome our television audience, by the way. It's 31 after the hour, so we are now on local television. So I think we could start this show. So let's get this thing going here. Let's roll channel number 1 and channel number 2. And here we go in 5, 4, 3, 2, 1. This is WeatherBrains episode number 683 for the 18th of February, 2019. This is the weekly show that's all about the weather. You know, we started the show in January of 2006. So we've been around for a long time, but we're still going strong. Dr. John is here tonight. Dr. John Scala, who is up in Lancaster, Pennsylvania. And so Aubrey, by the way, we're thin tonight. Aubrey, down the road from you, is dealing with a winter storm. Now, you going to catch any of this?
Oh, definitely. Yeah.
Looks like it's already started at the horseshoe curve.
Right. Well, we're going to see high pressure sit over us tomorrow. So we're going to start off with a cold ground. Our temperature will get to maybe 32 during the day. Clouds will come in, and we're already in a winter storm watch. So this is going to go to a warning, I think, because of the ice potential. So we're looking at 3 to 5 inches of snow probably during the day on Wednesday, but then we're going to go to ice. And there is a lot of liquid. If you've looked at the water vapor imagery today, that plume is coming from the Pacific, right across Mexico, and then right up into the Great Lakes. So this looks wet and it looks icy.
The old STJ. Yeah, we're going to send you a lot of moisture from down here in the deep south. We're going to be we've got gopher wood. We're building arcs down here, so getting ready for the week. So, but let's just kind of go through all the folks that are out. Again, Aubrey is preparing for the winter storm, and she's got some extra television work to do tonight, so she's out. Troy Kimmel, Bill, what has he got, an exam, I think?
He's giving an exam at Texas tonight. So I think it's weather and climate or something like that. So he's going to come give it to us next week. It'll be.
That's a good idea.
I would love to take that test. And then we've got Kim, who is ill. You know, so many people are struggling with something. A flu is just rampant across much of the country right now. So Kim is out. We hope she feels better. We know that Kevin's dad had some health issues, and I would imagine he still might be dealing with that. And Nate, we don't know. Apparently for Nate, it's 50-cent beer night at Hooters, so he's not with us. You know, Nate has that NBC O&O American Express Platinum card, so he can just go to town. But Bill, let's just bring in our guest. I mean, it's just us three, and we're going to have a great show. I can't wait.
Yeah, I have the WeatherBrains official from CBS reloadable Visa card. That's what I use for. Yeah, James, I'm really excited. Tonight's guest WeatherBrains, a professor in the Department of Meteorology and Atmospheric Science at Penn State. She is also the director of Penn State's Institute for Cyber Science. Her research areas are on hurricanes, climate change, and using advanced computer models and statistics. She's the current president of the AMS. Dr. Jenny Evans, welcome to WeatherBrains.
Thanks, Bill. Thanks, James.
Now you've had ample opportunity to run, and you haven't bolted yet. So we got you captive for the next 90 minutes now. So when we were communicating, you were in Australia. Is that work or pleasure, or both?
Well, it was actually both. I have all my family down there. I came from Australia, but I was also doing some work down there under my title of the director of Penn State's Institute for Cyber Science. So I was visiting Monash University, which is my alma mater.
And your degree was in applied mathematics, right?
Yeah, both my undergrad and my PhD were in applied mathematics, but my PhD started turning towards tropical cyclones, building a very simple model of tropical cyclone to understand how they evolve when they move.
Now, you had a little experience, not directly, but at least you were there for Tropical Cyclone Tracy in December of 1974, and that's an important tropical cyclone. Talk about it for a minute, Dr. Evans.
Well, Tropical Cyclone Tracy was important to me because it was Christmas Eve 1974, and I was a little girl, and I was asking my parents, how's Santa going to get there? You know, it's one of the critical questions that childhood asks. But Tracy was an amazing storm. It was so small It was about 50 kilometers across in terms of the gales. So if you think to Super Typhoon Tip, which was in the western North Pacific in 1979, was a huge storm, and the entire tropical cyclone Tracy fits in the eye of Tip.
Wow.
Oh my goodness.
If you want,
but it was quite intense, wasn't it?
Yeah, it was about 130 or 133 miles an hour when it hit land. In fact, it took out half of the city of Darwin, and literally half of it was decimated. One of my colleagues said he was a brand new forecaster up there, and he was minding a friend's house, and all he had to hand back was the bathtub. So Tracy kind of started me on tropical cyclones, and then it just kept going from there. After my PhD, I just got involved in pretty much the soup to nuts of tropical cyclones.
Hey, Bill, are you still there? Yo, Bill.
Bill, you've gone silent.
Yeah, Bill, he was working on some banana pudding. Maybe, I don't know what happened. Maybe he clogged his internet tubes or something there. Hello, Bill.
Yeah,
hey, Jen, I was going to.
When you get the banana pudding in the computer, that's what happens. Sorry about that.
Okay, you're back. You're back.
Yeah, I thought it was y'all. I was like fussing at y'all, but it was me. So
I was going to ask Jenny about the heat wave. Is that still happening? Because that was a huge story not that long ago.
Yeah, I was really glad that the 40 to 45 degree days had finished right before I got down there 2 weeks ago. The weather
was brutal. That is just absolutely brutal. Ugh.
Oh, I know. Yeah, I was so grateful that my parents had air conditioning. They're in their 80s, and that just wouldn't have been any good at all. I got perfect temperatures. In fact, I got mid to high 20s Celsius, and then I got back to mid to high 20s Fahrenheit.
Yeah. I didn't say we have mid 40s all the time here in the winter in Alabama. It's nothing.
I will say, right before I went, when we had that really cold spell, the difference in temperature between my home and my parents was 50 degrees Celsius.
Oh, wow. Wow.
Wow.
So how long have you been at Penn State, Dr. Ed?
I came here 25 years ago. I came here. I took leave from my job at CSIRO in Australia, and I liked it so much I never went back.
That is really cool. Talk about the department for a minute, and you've seen a lot of things happen there.
Well,
talk about that meteorology department.
Well, Penn State's the oldest and one of the largest in the country. I think we're also we're really well respected, and we have between 1 in 4 and 1 in 5 meteorologists in the country have at least 1 degree from Penn State. So that's one of our claims to fame. And they are loyal, and they're fantastic alumni to have. I am really thrilled to work with the faculty and researchers and students that we have here. And I've been really lucky to have some amazing students of my own. So the research I've been able to do here because of the quality of students has been amazing too. I've had some exciting times with that.
Yeah, I imagine they keep you young, don't they?
They really do. It's one of the fun things and the challenging things about being a faculty member is the students. It's really amazing group of people.
And one of your graduate students I saw, Miss Ocasio, I think, just recently won the AMS award for her hurricane research. And that was kind of a fascinating topic.
Yeah, so Kelly Nunez Ocasio came to work with me 2.5 years ago. She's a PhD student, and she's looking at African easterly waves and under what conditions a convective system evolving in an African easterly wave might become a tropical cyclone. And she's doing some really wonderful work. She's done some computer modeling to understand it, and most recently she's developed a new method of tracking the system she's trying to associate with the waves using satellite data.
So what's some stuff she can give to us operational grunts over here in the field to help us when we're tracking those 100 or so easterly waves every summer?
Well, right now it's in its early stages, but what she's trying to do is to track different mesoscale convective systems as they move through the wave, and then look at how they're interacting with the wave, and also what's happening in the boundary layer as they approach the coast, and see if you can pick up the ones that are going to go versus the ones that die as they cross the coast. So that's her goal.
Now, when you say mesoscale, are you saying like mesoscale like we know it, MESO, or a different scale that you're talking about there?
So, mesoscale.
Okay, so define that scale in relation to the other scales of synoptic systems we try.
So a couple of hundred to a few hundred kilometers across.
And so she's using satellite data predominantly, or surface observations off the African coast, or what?
She's tracking them using satellite data. She's using the UMETSAT satellite data. Then she's back at the moment. She's looking at a system systems from 2006. So she's able to use NAMA field data and also TRIM to assign the rain rates. So that way she can get a more
Talk about the importance of ensembles in modeling now in tropical cyclone forecasting and work you've done in that regard.
So something that's always been a motivator for me and for my students is trying to think about how we can contribute to improving the forecast. So what I've been working on lately being the last few years, is looking at ensemble forecasts of tropical cyclones and trying to think about a better way to characterize what's happening with the ensembles. So clearly you don't just take an average, or there's no real point in doing the ensemble. And there are some cases like Hurricane Ophelia in the early 2000s, I forget which year. And that system bobbled around off the Georgia coast for some time. And the models were saying it was going to make landfall in Georgia, which would have been like the third storm in 120 years, or it was going to go screaming up the East Coast. So if you took the average of those, it would go into South Carolina, right? Or Virginia. And so the average was meaningless. So what we've been doing is we've been using some really fun methods with statistics where you take either the geographic tracks that are forecast for all the ensembles or the cyclone phase-based tracks, and you use a technique that groups the entire tracks. So if you've got tracks going straight in over Georgia and tracks going in to Maine and tracks going out to sea, this method should find 3 groups of tracks. And then you can look at those and you can say, what's the population within each of them? And what's the characteristics of the storm? How large is it? How intense is it? What's the distribution of wind and rain? And if you look at those, then you can get a sense of the kinds of significant weather you'll get. And you can also look and make sure that the systems that are in one of these clusters are similar in their evolution. And in that way, you can give the synoptic evolution within each cluster to the forecasters so they can get a sense of, okay, this one's because the trough is staying well to the north. This one, the trough digs down and then, it's too broad, it knocks the storm over. This one, the trough digs down, so the one that recurves and it's a narrow trough and it pulls the storm up and out of the tropics. So that's the idea. So it's not a simple average, it's capturing the entire evolution of the system in the forecast, and it's looking at the whole synoptic pattern evolution, not just following a little billiard ball.
Yeah, that's very important. And then following that evolution as the synaptic pattern changes,
yeah,
and having that understanding. So that's really cool. Now, you've explored the relationship of sea surface temperatures and tropical cyclone intensity, especially given the implications of climate change and in the tropics. Talk about that for a minute, and what you've learned and what we know and what we don't know still.
So that's something I've done recently with Alex Kovalevsky, who's my postdoc. During his PhD, he did a lot of work on the ensembles. And so Alex got interested in, when you look at potential intensity theory, all the work that Kerry Emanuel and his collaborators have done over many years, to get the analytic solution, they made simplifying assumptions in the boundary layer. And first of all, we went back to look and see how they compared with the real hurricane boundary layer. And it turns out they were quite different. And so then we thought, let's simplify the boundary layer, but make it more like the real world. And so we took that idea and we said, let's look at the energy that comes into the boundary layer as a storm, as a trajectory. The wind circles into the center of the storm and it's picking up energy all the way, as you'd expect in a real storm. How might that change the intensity of a hurricane if you're thinking of it in the Carnot engine framework that Kerry proposed? So when you do that, if you assume everything else the same, you end up getting a storm with potential intensity up to a category stronger than would be predicted by the traditional potential intensity of Kerry and collaborators, even in like the 2012 paper. And so that surprised us. Probably it shouldn't. Well, when you think about it, it shouldn't, because you're getting more energy in at lower wind speeds further out where the friction loss is less. So you're actually getting a net increase in the energy input to the system. So that really intrigued us. So then, we looked at the sensitivity to the upper tropospheric flows as well. And then we started to wonder, could we be assuming that the storm was more efficient than it would be in the real world? We'd assumed the same efficiency as other investigators had, but if we drop that efficiency to, instead of a third, more like a tenth, which some recent researchers have suggested, then we come back to the same category as the original potential intensity theory. So I think we've got a lot to still figure out. Should the efficiency of the Carnot engine model we're using be lower? Is that more realistic? Should we be thinking of the energy input a different way? I'm kind of happy with having it be more realistic without constraining it so much that you over-determine the problem. But so we've still got some things to sort out there.
So what things do you think affect that efficiency?
Well, I guess it also depends on where the air is going on convection. And other than that, I'm not really sure at this point. Have to, that's way out there. We haven't started looking at that yet.
If you knew the answer to that one already, you would have already published it, I guess.
And I'd send it to you, Bill.
Talk about the Madden-Julian oscillation and its importance to tropical cyclones worldwide.
That's not something I've done a lot on. I looked at that a long time ago with Francine Jaskowitz, was my master's student back then, and George Sakriklides. And what we were looking at was how convection got organized in the West Pacific warm pool region. So there was a few field experiments in the late 1980s out in the warm pool region. Pogacor and Amex, Emex, and that set of three systems. And so there was some nice data from that. And that was the first foray I made into looking at satellite data to try and understand how convection organizes. And what we found there was if you tracked convective organization, and by that size and eccentricity, so the larger and more circular, the more long-lived a system is. So you see small systems getting more like squall lines, more elongated. And then as you saw the systems predominantly become more circular, they got even longer lived. And then out of that came potential for tropical cyclones. So through the course of the MJO, you go from relatively disorganized to getting more organized, more like squall line systems, then increasing organization, more symmetric, and then if you were going to get a tropical cyclone formation, it would happen about that time in the MJO.
Now, you've studied, extratropical transitions extensively, systems like Hurricane Sandy.
Yep.
Dare I say Superstorm Sandy, James?
Superstorm.
but talk about that as a complex system and why that's important to study that.
Well, extratropical transition fascinates me because I always thought of a tropical cyclone. It forms in the tropics, and when it tries to get out, it dies, right? That the environment outside the tropics is so hostile. Well, it turns out, as Sandy demonstrated, and as we know the 1938 New England storm.
Right.
In fact, if you go up to Maine to Pemaquid, there's a lighthouse at Pemaquid. There's also a local historian there has put together a short account of a group that came to settle at Pemaquid in the 1630s, and that a hurricane came up the coast, and the night they arrived, they all got off the boat except the first mate, and they were going to unload in the morning, and this hurricane came to the boat with everything that they had on board to start their new settlement. So Pemaquid was not settled then, they went inland. So you could even look at extratropically transitioning tropical cyclones as affecting the early settlement of the US.
Wow. That is amazing.
I wish I could remember the name of that historian, but if you go to Pemaquid Lighthouse store, you should be able to find that account.
I think we need a road trip, James.
Road trip. Let's go. Let's do it.
I became convinced that these were important, and Bob Hart was my PhD student at the time, and I thank him for really pushing me to look into that. That was what he did his PhD on, and it's fascinated me. So, as I said, you get storms forming in the deep tropics, and they form using the ocean energy source and convection to organize it and increase the intensity, and people listening, know what's going on there. But as they move out of the tropics, you go from this warm, moist, relatively low shear environment to typical mid-latitude environments. And so the question is, how does that happen? And what we came up with was that if the system, first of all, a system that survives extratropical transition is already strong as a tropical system. It's going to encounter shear. And if it's a weak system, it's not going to survive the shear. So you've got a relatively strong storm that's being steered out of the tropics. As it's getting steered out of the tropics, it's getting increasing shear and decreasing temperatures. And it's a trough that's steering it. If the trough is broad, you get a large amount of shear, and the system's also going to die. If the trough narrows so that it's more on the scale of the tropical cyclone as the storms are interacting, then the tropical cyclone can survive that interaction, and you evolve a mid-latitude structure of that storm. And so then the storm basically accommodates its new environment. The cool thing is you want to follow this just using, look at equivalent potential temperature. It's a fantastic tracer, because if you take the theta E, you see this incredible warm, moist anomaly in the tropics, and you can track a storm all the way out well into its ET phase by looking at that theta E signature. It's really pretty cool. And if you look back to Hurricane Charlie in 1986, was one of our early poster boys. And something, if you think about the insurance industry, if you've got any folks that are interested in that, extratropically transitioning tropical cyclones can be a nightmare for the insurance industry because you get correlated losses. So these systems are typically very intense. So typically they're going to form in the main development region in the tropical East Atlantic. And then they come across, they can make landfall in the Caribbean, in Cuba, in Southeast US. Recurve, they can hit the US or the Canadian Maritimes again. And then they go out to sea and they make landfall in Ireland, the UK, even Scandinavia or the Iberian Peninsula. So correlated losses like that are not something that I would want if I was running an insurance company anyway.
No, that's not good news, that's for sure.
Well, and the other thing is that they're really difficult to forecast because as they evolve, the winds to the right of the system, now the system's moving so much faster as it leaves the tropics. So it becomes very asymmetric, and the winds, typically it's to the right of the system, it's much stronger asymmetry, right to left. And typically the rain shield moves to the left, so west. And so that means if you get an error in the track forecast, you can get very different significant weather. And if you think of systems that interact with Japan or, Taiwan or wherever, but particularly Japan, if you've got winds versus rain relative to the sort of topography that you see there, it can be a very different outcome.
Talk about Sandy for a minute. What you were watching? I'm sure you were watching it intently as it approached the United States. What did you learn from that system?
I learned that being in central Pennsylvania was a bad idea. Got nothing. Disappointed students in the weather station.
That's always the case.
Here comes the storm Sandy. And, West Virginia's getting snow.
Right. Record snowfall.
All this weather. And we got, not much at all. And people were still going to the supermarket buying water. What's up with the water thing?
It's milk and bread here.
Yeah, milk and bread is the same thing. We don't get it.
It makes a bit more sense. I mean, if your water goes out, you've got an entire hot water tank full of hundreds of gallons of water. You've got all that there to drink before you lose water. I mean, anyway. So the thing with Hurricane Sandy was it was so predictable. Like we started looking, it's so predictable that you didn't believe it, right? Because we started looking at the forecast before it even got to Cuba, and the track was pretty well forecast then, almost to landfall. And then even when you looked at the ensembles, didn't matter which model you looked at, that hook left was being got by the vast majority of the ensemble members even. And that's not a usual track. So that was a surprise. And the models did really well, which made it, So what we did notice, though, when we looked at the ensembles, when we did the clustering that we like to do, was that the structure of Sandy, whenever the model Sandy made landfall, was pretty similar in all the ensemble members. What was different was when Model Sandy made landfall, which is interesting. So the actual evolution of the storm in that case was very similar ensemble member to ensemble member for the vast majority of them. What was the biggest difference was when it made landfall. But if you did everything relative to landfall time, they all looked very similar.
Mm. That's fascinating. So you and Bob Hart have a really cool page. It's going to be my pick of the week tonight, which is relates to tropical cyclone evolution, phase evolution.
Yep.
And talk about how to use that tool. And when we're looking at these hybrid type systems that befuddle everyone during the Atlantic hurricane season.
So that was designed for us to think about extratropically transitioning systems. Because if you think about it, you're trying to think about evolution from this deep warm core system with maximum winds near the surface to a cold core, tilted cold core system that's much larger with maximum winds near the tropopause. And so how do you characterize that in a way that you can really discuss and make sense of? And so we said, okay, well, let's think about how to simplify that down. And we decided tropical cyclone symmetric, extratropical cyclone asymmetric. So we wanted a symmetry parameter. And then strongest winds near the surface, strongest winds aloft. So we wanted something to capture that. So we fiddled around with how to do it exactly. But what we came up with was essentially a lower and upper tropospheric metric, or that related to the thermal wind, and then a lower tropospheric symmetry metric. And so B is the symmetry or barochronicity. Then we have a lower tropospheric thermal wind, upper tropospheric thermal wind. We chose the layers we did by looking at when NHC had declared transition in historical cases. And so the lower troposphere became 900 to 600 hectopascals, and upper is 600 to 300, and it works really well. And then because you want to capture the tropical and the extratropical, it's a 500-kilometer radius, so that you can capture enough of the extratropical system to get that tilt. So that's the basics of how we got there. What you'll see, if you look at it, we mainly look at the lower troposphere. So the lower troposphere, you've got the symmetry against the thermal wind, and a tropical cyclone is, if you look in the quadrants, I can picture it, and I'm hoping you've got a diagram you can show people. You've got the quadrants. The bottom right is warm symmetric. The top left, so the top left is cool and asymmetric. So you start in the bottom right. If you're an intense tropical cyclone, you go further and further and further to the right, and that's getting more and more intense. Higher and higher thermal wind, stronger surface winds, but staying symmetric. And then as the transition begins to occur, the storm goes, it first of all just stays in that symmetric range and moves back towards the center of the diagram. And then it starts to become more asymmetric. And then eventually it gets lower troposphere cold core. And that's when we say, so when it hits a certain level of asymmetry, we say extratropical transitions begun, and that number is 10, which is pretty amazing. It's a very small asymmetry, right versus left of the storm track. And then ET is completed when you see lower tropospheric cold core. So when winds aloft are stronger than near the surface. And it's a simple 3-parameter space, but you can really show a lot. You can see subtropical storms form in that intermediate space of asymmetric but still warm core. You can see occlusions You can see all kinds of different systems and you can follow their path. So it's a great way to summarize the evolution of a system in 2 or 3 parameters, you know, rather than trying to, I mean, and it's physically, it's tied to the physics. It's not just, you know, pick a contour or something. It's tied to the evolution of the whole system. And so we were really proud of that. And if you look on Bob Hart's Florida State website, that's where he keeps this operational page that shows you all of the forecast models. It's got some satellite diagnosed phase space as well, and a bunch of historical cases you can go and look at. It's really wonderful. When I'm worried about a system, I go there and look because I want to know what's going to happen to the structure.
So talk about the system real briefly before Dr. John has some important questions to ask you. The system that's off the northeast coast of Australia right now. What's the prospects for that one?
I've been on a plane for the last 2 days, so
you flew over it. Yeah, it looks like it's going to be an interesting system, not a really strong system, but so you're using the ensembles and different deterministic model output to go into that page,
yep,
and make forecasts of what it. So that's really something important for us to look at as we're studying the transitions, right?
Yeah, and so I talked about doing the ensembles and clustering, making those groups of similar tracks. We've done the same thing looking in the cyclone phase space. So instead of saying where the storm's moving, saying how is its structure changing. And those give largely similar, although not identical results. So we're trying to understand where the nuances are. And we're also interested in looking at some work that Julia Keller and Sarah Jones and colleagues have done, and Pat Ha, summarizing how the environment changes, not how the storm changes. And so we've done some work with them comparing those 2 ways of looking at the ET evolution.
That's fascinating, Jenny. I thought a lot about Sandy because it produced some physical attributes that there was a group, let me say this, there was a group at Rutgers that did a study asking the question, well, how often can you expect the large-scale environment to be in place when you have a tropical cyclone moving to the north at that time of the year and intersect the New Jersey coastline with an astronomical high tide? How often would all of these attributes come together at the same time? And their analysis, almost like a Monte Carlo simulation, came up with a return interval of about 714 years.
My goodness.
So
yep,
the mayor of New York was telling everyone that we got to be ready for this kind of thing. We got to be ready for flooding from any kind of tropical storm that's coming north. Well, yeah, some of that's true, but the recurrence interval of 700 years tells you probably don't need to worry about it to that magnitude all the time. My question, though, is taking a look more about some of the advances that are taking place with NOAA with respect to the next generation global forecast system. And you can access now the FV3, the finite volume cubed sphere dynamical core. That's out there now with the GFS. Have you had a chance to look at that? And what do you think of the improvements that are coming down the road with that?
I haven't had a look at it enough to understand what improvements might be there. I think it's, I'm excited to see people taking a different approach with the forecast models. I think we've done amazing work with forecast models, and yet there's still room for improvement. I mean,
absolutely.
This is true. And so having a new approach and a new framework, I think, is important. But yeah, I haven't looked at it much lately, so I'm afraid I'm not good to answer that.
I'll be honest with you, John. I think a lot of practitioners down here my level are going, it's not quite ready
that's what
for
I've read, James.
prime time.
Right, yeah, that's what I've read too.
I have dabbled in it, and again, I've got access to it, but and again, I don't like to be critical because I don't have the mind of a modeler, but it has not performed well in a number of circumstances with high impact weather here. So we'll see. I mean, it's going prime time one way or the other, I understand. So when's the date, John? When is it operational?
That's a good question. The shutdown, the federal government shutdown, probably threw a wrench in that work. So I don't know if that's delayed it or not. March, maybe?
Well, we'll see. Hey, Jenna, I got a question while we're picking your big brain here. One of my frustrations, and I'm old as dirt, but we're still using upper air observations from radio sondes and weather balloons like we did in the 1930s. Mm-hmm. And to me, this is one of the biggest limiting factors. It's the lack of real-time upper air data. Where is this going? Is there any hope for better upper air monitoring in real time in the next generation?
Well, I would hope so. I think that we need to keep on the satellite. Every now and then we hear that the satellites are going to be defunded or reduce funding and so on. I think it's critical that we keep there. I'm also excited about the ways we're doing data assimilation and taking advantage of the data we have. I boast, so as director of Penn State's Institute for Cyber Science, I get to talk to a lot of people who are doing really complex models, and I boast about weather forecast models and climate models and so on. And what I boast about is that we take these incredibly disparate data sources, different spatial and temporal resolution, and we integrate them in a physically meaningful way that's skillful enough that we can make these forecasts. And we need better upper air data always. But I think that what we can do with whatever data we have is really pretty amazing. So
yes,
it's a proud boast, actually.
Well, we need to do that accurately, because isn't it something like 90 or 99% of the input data in the initialization is from satellite and radar?
Yeah.
And go ahead, Jen.
Well, I was just going to say, I think we have new methods for thinking about how to use those perhaps more effectively. So everyone's talking about artificial intelligence and machine learning and so on. But it may be that we can train systems to decide what are the underlying structures of the atmosphere, to recognize that, and to then make sure that we get the best possible coverage from the data we're selecting for the model in certain areas, and increase or reduce tolerances, make things as anyway. Sorry, brain burp. Anyway, so to use those as a way of helping pre-select data we would put into the assimilation system.
Good. Can I change subjects here? Go ahead, James.
No, you go, John. I want to shift subjects too, but you go first, and then I'll do my change after you.
Okay. All right. Hopefully we'll do this without stripping gears. So I read an article recently talking about, I'm going into the climate change arena right now. And I read it really interesting. No buzzer necessary.
We're buzzer free tonight.
Buzzer free, good. Interesting article I came across talking about tropical entities in the Mediterranean, how that might, with climate change, result in more of these, more intense of these. In 2017, there was quite a tropical-looking system in the Mediterranean. Any feel for that, Jenny, in terms of that kind of attribution of climate change?
I have looked a little at those systems. So I've done some work with a really smart Spanish now PhD, Juanje, and yeah, I mean, I think it's certainly possible that we'll get more of those systems, and they do have a lot of characteristics of a subtropical system developing into a looking like a weaker tropical system.
Right.
Yeah, I mean, it's possible. It depends on what the limiting factor is in their life cycle at the moment. I mean, it's, yeah, I think that will be one to look for. I've been doing a little work with some folks from, right it again, Columbia University. And
it's a change in hemisphere. That's what it's doing to you.
Yeah.
Still the jet lag. It's my excuse. So trying to think about how we can use the cyclone phase space in climate models to think about extratropical transition. And so Melanie Bielli is the lead student on that, and Susanna Camargo and Adam Sobel. So I think that's interesting. We managed to show that we could look at a version of the cyclone phase space to track systems in a climate model. And then we're trying to look and see how that might show differences in a climate change scenario. Because I think we all care too whether or not Hurricane Sandy is better than a 1 in 700 year event. Although I will say too that you can get 2 1 in 700 year events in the same year, and then just hope that the next 1,500 are clear, right?
Oh, yeah. Flooding tells us that. The flooding we've experienced in the last 6 to 12 months here tells us that.
Yeah, yeah. Definitely.
All right, Jenny. So let's shift gears. I want to talk about the AMS. So you are
president, James.
You are the incoming president, and tell us about your goals for 2019 as president of the American Meteorological Society.
Yeah, well, Bill was cheering there. I'm the 4th woman president, so I'm excited about that. 4 in 100 years. Mary Glacken will be the 5th woman president next year, so we're picking up speed. But this is the centennial year of the AMS, which I think is amazing. And when you look back to 1919 and you think how far our field has come and the amazing things we've done, like I sat there and thought, what are the achievements I'm most proud of in our field? And then you think back 100 years ago and you try and say, who made a critical contribution to getting where we are now? And what was the insight or the instrument or, you know, what combination of things came together so that we could get from just sort of looking at the atmosphere to coming up with baroclinic waves to coming up with the kinds of models of weather systems we have now that let us do these amazing forecasts. You know, just I think, you know, people say, but you're a meteorologist. Why do you run the Institute for Cyber Science? Right? The Institute for Cyber Science is all about complex models and big data. And I say, well, in 1948, John von Neumann had a programmable computer.
Right.
And guess when the first numerical weather forecast was? 1950.
Wow.
So we are the original big data science. I think that, you know, that's one of the amazing things that we've had was being able to translate. I mean, we have the fundamental equations, we have observations, they're getting better all the time. We're able to build these more complex models. But, you know, so that's where I've been thinking about where we were. And then thinking about where we are and where we go next. I say to people without any irony at all, my students want to change the world. And that's one of the things you talked before about working at a university. That's one of the things I love about working at a university, right? and to make an impact in their work. They're happy to work together to find ideas from all over the place. In fact, I found the clustering work I'd been doing for the ensembles, I found that completely by accident. I was visiting a friend, who's a kinesiology professor in Verona, Italy. And she was working with one of her grad students, and I was bored, so I started reading through her journals, and I found this idea. So that's this serendipity thing. So anyway, you think of Hurricane Harvey or Hurricane Maria or any of the other really devastating systems we've seen in just a very few years. You don't have to go back very far. And how important our community is and how much we're at the center of things in trying to keep people safe. But if we take the lead in a larger group of people, whether it's, in the case of Harvey, you can think of hydrologists and town planners and all of those people, but you can also think about community leaders and many other fields. We can be the ones who bring those teams together and really make a difference. And we are in places. I mean, people are doing that, but I think we need to look at ourselves in that way as being essentially the pivot for helping society be more resilient and bringing people together and being willing to be leaders. So that's kind of where I see things changing. I'm not sure where the technology is going to go. I just know great things will happen. If it's anything to go by the last 100 years, and I know that sounds flippant, but it's not meant to be. But I really
glad Kevin's not here to hear that tonight, James.
Who?
we have an anti-social media person on ours. Well, not anti-social media. He has a problem with some of the irresponsible elements of it.
Yeah. So Jenny, I think in recent years, those of us in operational meteorology, the practitioners down here, feel as though the AMS has reached out. I think it seemed to me it started about the time Marshall Shepard got involved. This was back in 2013, I think, where for a long time, a lot of us felt no interest in the AMS. Like this was academia and research, and they're just not interested in those on our front lines down here. But it seems as though there is an interest in bringing all of these areas together, and I think that's been the case. Don't you feel that way?
Yeah, absolutely. I think that the AMS, what we want to do is to recognize the incredible talents of all of the meteorology community, not pick one group. And, the more and more we meet the kinds of situations I was just talking about, the more we understand how many talents and how many different skills we need. And yeah, frontline forecasters, frontline meteorologists, these are the people, these are the first scientists that comes into someone's home, right? I think.
Yeah, I think that is the case. And again, now you've got those that work for it, not just television meteorologists, the National Weather Service forecasters. With social media, they come into people's homes. They come into their phones. So you're right. I mean, and I just think that it just seemed to me, again, I've been doing this since the 70s. It seemed to me for a long time, people that do what I do, they say, I'm going to go to the NWA meeting, and I have no interest in going to AMS. There's a bunch of academic people that mock us and belittle us. And, if you don't have a PhD, you don't even belong there. But the times I've attended the AMS sessions in recent years, I never felt that. Now, it's overwhelming. It's awfully big, and it takes some planning, but I never felt unwelcome. So I think that's changed a lot over the years.
I would hope so. I mean, I think that I've certainly felt comfortable there, and I meet all kinds of people there. I got a lot to learn.
Yeah, and again, how do you see the AMS and the National Weather Association relationship? Do you ever speak with the leaders of the NWA, or just everybody stays separate?
I don't think we need to stay separate. I mean, I haven't been involved in the NWA myself recent years with the Institute and my students and everything else, I haven't had a lot to do. But I think we all have to work together. We're also working with the AGU this year. The AGU turns 100 as well.
Right.
And so, and the AAAS also turns 100. 1919, I think everyone decided we needed a fresh start on so many ways. Right?
Wow.
It was time to get our heads together and find exciting challenges. So all of these 100th anniversaries are happening at the same time. One of the things we did when we were thinking about what makes the AMS special, you know, so the AGU was all earth, atmosphere, ocean, ice, everything. So maybe we should just sit in the AGU. Well, the thing that we decided made the AMS special was exactly what you were touching on, James, which is the AGU is very much in the research realm. But the AMS takes it from the research realm through all kinds of technology and understanding and development to where the rubber meets the road, getting the message to people, affecting policy, affecting sort of the way things are done. And that's what makes the AMS special, is that we captured that entire trajectory of taking fundamental science and, you know, delivering something or having something that we can't deliver and saying back to, you know, working on it all along that sort of continuum to find the answer. So that's where I think the AMS and NWA are very distinct from the AGU, and that's what makes AMS special.
Jenny, I served as president of the NWA a little over 10 years ago, and I agree with what you're saying and what James is saying. We're not mutually exclusive societies or organizations, and almost all of us belong to both.
Yeah.
And I think there is a real interest in the last couple of years to try to bring those two groups back together again. There was a split, 40 years ago, but I think that's in the past. And I think the current members of the organizations of both think that we could serve each other much better by coming together.
Yeah, I absolutely agree. I think we have, we don't have any reason to try and put up fences. I mean, if you don't want to learn from your colleagues, you become irrelevant pretty quickly.
So you've been in this position, Jenny, for about a month or so. What do you see as your biggest challenge this year with the AMS and your leadership position?
Really, I think something that we have a long way to go is having a really diverse society. And I say that in full knowledge that an enormous number of people have put a huge amount of effort in. And the AMS has made strides. But what I mean too, what concerns me is if you think of Hurricane Maria and how that impacted Puerto Rico, and you think about, I mean, me sitting here, I would have every intention of helping in any way I could, but I wouldn't understand what was going on there in the way that someone who had more knowledge of Puerto Rico and specifics, but also just maybe an island with that kind of topography and distribution of population, right? And so having a diversity of experience, I think, is critical in order to do what we do well and to really make a difference. And so I think the challenge remains to increase the diversity of the AMS and to be even more inclusive. So it's been said before, I think we have to keep saying it because we still need, that's something we still have as a challenge. And I think it's not just, I think it's important in many ways. And so that, I think, is something I really want to see us make some progress.
So how often do you go to 45 Beacon Street, or do you go to Boston at all as part of this position?
Oh, yeah, I do get travel as part of this position. I get to Beacon Street a few times this year and enjoy the view, enjoy the common. But I'm also going to be at a number of other AMS meetings. I think it's important to do that. And actually, the one thing that I didn't realize is I would represent the AMS at the European Meteorological Society meeting. So at the AMS annual meeting, we have colleagues from Europe and Asia and Africa who come to contribute to our meeting. And so I'll be doing the same at the European Meteorological Society meeting, which I think is going to be really exciting.
That's really interesting. Really interesting.
That's awesome. You know, I go to Boston every summer, and I have been by the AMS headquarters probably 8 times in 8 years. I've not walked in there. One of these years, I'm going to stop. I'm going to stop and go in there and just say hello and just say that I've been at the 45 Beacon Street. But I literally, we walk right past it every single year. But we're so busy and there's so much going on here. But Jenny, I don't know. Do you need to go, or can you stay a few more minutes?
I can stay a few more minutes if you'd like me to.
Okay. Well, I'll tell you what. Let's do this. I know it's late. It's 10:32 Eastern. So you've been with us for an hour. So thank you for your time. We know that you're awfully busy. So if anybody wants to get in touch with you as the AMS president, do you have a special Twitter account or email address? What's the best way to do that for those that might want to get in touch with you?
You can find me on the Penn State Meteorology webpage.
Okay. There you go.
5 women on the faculty, so it's pretty easy to figure out which of us is which.
And give us, before you go, give us a plug for the Penn State program one more time. You gave us a little bit earlier, but just for and we have a lot of kids that listen to us that are in high school that are interested in becoming a meteorology major, atmospheric science. Why Penn State? Give us a good, so you get a free commercial for being on the show.
I think that we have an incredible program. So I like to think we give our students the ability to take complex data, understand what the errors are around that data, integrate that data, and in a timely fashion, give a forecast, give a decision, and communicate it. So we do that incredibly well at Penn State. That's a skill base in addition to the knowledge base you get. And we have all kinds of areas. You think about it, you can study the poles to the tropics, you can study an individual cloud element to the stratosphere, and everything in between. You can study how weather affects society and economics and risk, all of this. And
Bill, you okay there?
Maybe
wow, what was...
Anyway.
Somebody is printing something, and it prints out down here in my weather office, and I had nothing to do with it, I promise.
No. Sorry, Jenny.
We have an amazing department. We have amazing students, and if you want to be an amazing student, you should come to Penn State.
Awesome. Well, again, Jenny, thanks a lot. And again, we appreciate I know that you're not paid a whole lot of money as AMS president. This is a volunteer thing where you're sacrificing your time and energy. So thanks on behalf of the Weather Enterprise, thanks for all the work that you'll be doing this year. Thanks for coming on the show tonight.
No worries. Thanks so much, Jenny.
Yeah, thanks, Jenny.
Thanks, Jenny.
Okay. Thanks a lot. We'll talk soon. All right, let's take a break, and we're going to have Tony Rice and the Astronomy Report. We're going to come back with Picks of the Week, Weather Roundup, and much more as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your Astronomy Outlook.
Last week, a WeatherBrains listener shared an article that he'd seen in a British tabloid with a headline that shouted, NASA asteroid warning, giant asteroid headed for Earth, approaching tomorrow at 29,000 miles per hour. Now, other sources of similar reputability are picking up articles like this, and they show up on Facebook feeds and other social media sources. One yelled, NASA warned people of massive asteroid headed to Earth this weekend. Now, both were referring to asteroid 2019 CB2, which, yes, did pass Earth in the early morning hours of Sunday, February 10th. But buried at the bottom of the article is the fact that the asteroid was expected to and did miss Earth by more than 650,000 miles. Not only is this bad science and bad journalism, it's not even particularly good clickbait. Why they picked CB2 to get in a lather about when just 24 hours later, 2019 CN5 passed 8 times closer. I don't know. But it speaks to the overall process, I guess. That same tabloid reported this weekend that a monstrous, all in caps of course, asteroid measuring just over 280 feet in diameter will near miss the Earth next week at more than 30,000 miles per hour. Magnitude adjectives aside, all these facts are pretty much correct. But one important figure was left out of the article. That rocky visitor will pass more than 14 times beyond the distance to the moon. So everybody just settle down. So where's all this coming from? As I skim through past articles, the similarity between them makes me think that there may not even be a human involved in creating them. When you look at them all at once, they start to look like Mad Libs, and they all go something like this. NASA asteroid warning. Space rock will hurtle, barrel, dash, or some other speedy verb past Earth today. The article generally includes the astounding speed of the rocky visitor as well. Spoiler alert, they're all going pretty fast, generally between 3 and 25 kilometers per second. Let's stop and think about that for a minute. That's why they're in the orbits that bring them close enough to be classified as near-Earth objects. So-called is also placed before any mention of the phrase near-Earth object for some reason. Why these so-called journalists feel the need to cast doubt on scientific classification is beyond me. The opening paragraph generally ends with NASA's asteroid trackers have revealed. While this may conjure up an image of an intrepid reporter prying information from a reluctant scientist about some dangerous asteroid, nothing could be further from the truth. All this information comes straight from data openly published by the Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory. You can visit cneos.jpl.nasa.gov and click on Close Approaches to see them for yourself. You'll quickly discover that this isn't a big deal. Space rocks pass harmlessly by Earth nearly every day. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
When the weather ball is red, warmer weather is ahead. When the weather ball is white, colder weather is in sight. When the weather ball is green, no change in the weather is. Spoilers blink by night or day, precipitation's on the way.
We are doing this show on the 18th of February, 2019, and time to talk about weather across the United States. So, John, you've kind of given us a quick briefing, but you got snow, ice, wintry problems on the way.
Oh, we do. Let's see if we can screen share. Here we go. I know that many of you are listening rather than watching, but you ever have a chance to go to the Null School site and take a look at the streamlines that they put on there? It's spectacular. And what I'm showing here are the wind speeds at 500 hectopascals. And there's our problem. North of Baja right now, it's an amplifying trough out in the west. And that's what's going to be tapping this moisture coming east. And if you're looking over the Bahamas right now, this would be a perfect time to be in the Caribbean with a huge anticyclone sitting there. And I have a brother who has this uncanny knack of being able to head out of town when the weather's going to get bad here in the east, and he heads to Key West. So he was telling me today, sitting in a bar, how nice the weather was. So all of that weather,
that upper high is just strong, man. It's a classic battle between this cold trough in the west and the upper high over the Bahamas. Now, funky Nassau is the place to be right now.
Oh, without question.
Like
and it's just funneling all that moisture from the eastern Pacific right into the mid-Atlantic. So yeah, James, we're looking at snow and ice on Wednesday.
And while we got that up, but I was going to say, I was looking at what the Weather Service out in Flagstaff is forecasting. And this is pretty remarkable. They are forecasting for Flagstaff 18 to 24 inches of snow Thursday night into Friday. And some of the locations south of there could see more than that. So it's going to be a big snow producer for those southern mountains out through there, the southern Rockies.
Yeah, let's pull up the water.
Flagstaff rail cam is going to be in great business. Yeah. Thank you for that tip, James.
Yeah, there's an upper low actually right over Flagstaff right now.
Yeah, it's and that's just trouble for down here where we are, Bill Murray. We're going to have rain. I was looking at the European ensemble mean from the 12Z run, and it's still printing an additional 6 inches of rain for most of our area here. Birmingham, Tuscaloosa, Anniston, Gadsden, Alabama. And that's going to create the problems for aerial flooding, maybe some flash flooding and longer-term river flooding. So it's going to be a big mess. And then on top of that, we've got a day 6 severe weather outlook from SPC as the trough lifts out, which is Saturday. Day 6 is Saturday, and this includes all of Arkansas, basically the broad area from Shreveport up to about Evansville. And so as the thing kicks out, we could see some severe weather. So it's going to be a very fascinating week for our weather watchers. And goodness, I guess we'll all have stories to tell next week. But let's do Picks of the Week here because I'm the lead story on the news tonight. We have to get out on time. Picks of the Week, it is that segment where we share something that is weather related. This can be a website. This can be hardware, software, anything like that. So let's start with Dr. John and see if Dr. John has a pick of the week for us.
I do, James. We've been talking about, actually, it was a couple of weeks ago. We had some guests on. We were talking about ham radio, and we got into the subject of reporting severe weather in the Midwest. So my pick of the week takes me back to February 18th, which is today. We're going to go back to 1992, a rare F4 tornado in Van Wert County, Ohio. And so I dug out the old storm data from that day, and my pick of the week talks about that event that occurred in Van Wert County, Ohio. It was an F4, a very rare event.
Awesome. Yeah, that was one I clearly recall. I was working forecast shift that day on television, and that was nasty, and that's unusually far north for this time of the year. Just fascinating. All right, Bill, I see your pick of the week in the chat session there. What you got for us?
Yeah.
I had the foghorn ready to go. I mean,
well, I had to have one tonight in honor of our guest because she played a large role in the creation of that site at Florida State with Dr. Bob Hart that I've used a ton this year because we had so many hybrid systems. And I think it's fascinating. So that is my pick of the week there. And I think Dr. John is clicking away on it there. Of course, James, we're moving into National Weather Podcast Month here in March. And we've got a lot of exciting things that are going on over in the guest department. But next week, we'll have Tim and Alex from the National Tropical Weather Conference. We're going to be out there in early April. So they're going to be able to talk about that along with Rick Reichmuth. And then we're going to have Hurricane Schwartz. Glenn Schwartz will join us on the 4th. That's going to be a great show. We'll have Joel Hausman from Ice Station Hausman, part of the National Weather Podcast Month. The Tennessee Titans punter, I almost dumped him off the schedule, James. He's already done the Weather Geeks podcast. So, yeah, I need a vote tonight, majority vote. Does he get to stay or do we have to kick him off?
Ooh.
Oh, he can stay.
Okay. All right. I was just, we were jilted, but we'll just fuck it. We're going to talk about the MSU, the Mississippi State Symposium. Shay Gibson will join us that week, the 18th. And James, you get Dr. Chuck Doswell all to yourself, you and Dr. John, on the 25th of March. So he's gonna join us that night. I will be coming from the Temple Bar in Dublin, Ireland, with some Irish WeatherBrains fans. So
we ought to do a meetup.
Yeah, come join us, James. We got a space left on the tour for you, but we got lots of great shows. I mean, we've just been adding guests right and left. We're going to be talking hazard simplification on April 1st. On April 3rd, this is going to be a special Wednesday show, James. So go ahead and mark it on your calendar. We'll be talking to 4 directors of the National Hurricane Center, including Dr. Neil Frank.
How did you get Neil Frank? That's amazing.
Bill Reed, he's got muscle, I'll tell you.
Yeah, Bill does, yeah.
So we're excited about that. Tim Heller is going to join us on the 15th. Harold Brooks, Victor Gensini on the 22nd. Gary Woodall on the 29th. It just goes on and on and on. We're going to have some great shows coming up in the coming weeks here on WeatherBrains.
All right, awesome. Well, let me do a quick screen share here. In fact,
I'm locked on Dr. John now somehow. How'd that happen?
Let's see here. All right, so here we go. This is my pick of the week. This was an article in Science magazine. So how far out can we forecast the weather? Scientists have a new answer. This was published on Valentine's Day last week. And obviously for people in our business, it's a quite interesting read. And again, the link, it's going to be up on the website, weatherbrains.com. While I was screen sharing, I was showing some of the countries that listen to us. We kind of, we were looking at this, and obviously the United States is number one here. Let me see if I can get this thing. Anyway, Ireland is number 2.
Yeah, how did that happen?
6,000.
This
was like 1 week.
That turning it off and on again song.
But this was just 1 week. The United States, 20,715. This is just audio listeners. Ireland is number 2 with 6,630. Then comes the United Kingdom, Canada, Australia, France, Germany, the Netherlands, Iran, Switzerland, Korea, Israel, New Zealand, Norway, Mexico, Argentina, UAE, Denmark, India, Japan, Spain, Iceland, the Czech Republic, Puerto Rico, Hong Kong, Portugal, and it just keeps going on. But why in the world is Ireland with 6,630 listeners? How does this happen?
Well, for that Irish meetup, we're going to have a bigger boat, I think.
So Bill is going to go he's going over there for one reason, to have a WeatherBrains meetup in Dublin. So
I'm going to build it back to the company. Is that all right?
Yeah, if you're gonna listen, good luck getting that money back. If you listen to us in Ireland, send us an email. It's email@weatherbrains.com. We'd love to hear from you, and we're trying to.
We can actually do 2. We can do one in Galway and one in Dublin. So just get ready. Get ready, Ireland. We're on the way.
There you go. Now we should do more WeatherBrains meetups. Anytime I'm at a weather conference, I'll do one. And we have the most interesting people that show up. I mean, I've done them all over the country, and I've even had people come up to me at baseball games, and it's very interesting to meet our WeatherBrains listeners. But anyway, Aubrey again is out. She's got a winter storm coming, so we will do a long email segment next week. But again, I am the lead story, and we have got to wrap this sucker up here. So thanks a lot for listening. If you'd like to send us an email, the email address, it's email@weatherbrains.com. The social media accounts are up on the website. Show notes as well. And Bill, be sure and send your pick by email over to JP so we can put it on there. We typically are on the air Monday nights at 9:30 Eastern, 8:30 Central. And a lot of folks watch us at live.bigbrainsmedia.com, but we know most of you listen. So on behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Have a wonderful week, and God bless.
Thanks for being here, Dr. John.
My pleasure, guys.
Thanks, everybody. Y'all have a great week.
You too, James.
Bye-bye.
See ya.
Bye-bye.
Bye.